This video provides the information of ERG orbit dataset and how to use this data to plot some figures. Before starting this training course, we would like to announce some points. First, this course will use the ERG plugin tool based on the IDL SPEDAS. So please update your ERG plugin as the latest version. You can go to our webpage, ERG Science Center, go to the analysis tool, and you can find the latest version on the website. Also, ERG Science Center provides lecture for the beginners of IDL SPEDAS on our YouTube channel. If you utilize ERG orbit data for your study, please cite ERG orbit DOI on your publication. Finally, if you have any questions, please feel free to contact us. Goal of this training is to learn how to load and plot orbit data of the ERG satellite with a special focus on plotting satellite trajectory in space and ionospheric footprints on the world map. This video will follow these contents. First, we would like to provide the information of the ERG orbit. Then, second chapter, we provide the information how to plot the orbit data. Especially in this movie, we provide a time series using t-plot and space trajectory in xy or xz plane in space. Finally, we provide the information how to draw the ionospheric footprint on the world map. Also, this handout provides additional information such as information of the coordinate system and meaning of the L neckline and the L star. ERG orbit data consists of the two different levels, level 2 and level 3. Level 2, we only use the internal field model using the IGRF. Level 3, we use internal model plus external field made by different type of model. This section shows how to plot the ERG orbit data. So first is time series using t-plot command. So for first thing, we should set the time range. So in this time, I choose this time interval. Let's see. Time span command set the time range. Load level 2 definitive orbit data. And this load procedure store the data into different t-plot variables. For example, here. Now we learned how to draw satellite trajectory into two-dimensional plane. Time span and the load procedure are the same as previous slide, and now we practice t-plot xy command here. Let's see how this works. So we can see satellite trajectory in xy plane here. Without any command, they automatically detect mean and max value and set xy plane. Now we practice more about t-plot xy using the different keywords. So we can choose x and y range using range keyword. Also, we can switch axis as xy to xz. Let's see how it works. This slide gives us additional information for t-plot xy and plot xy. Both commands are almost the same, but only difference is t-plot xy use a t-plot variable. On the other hand, plot xy use a variable, kind of data array. Now we learned how to project ionospheric footprint on the map. So for this work, we should initialize the map 2D environment and set the coordinate system. So in this time, we choose geographic coordinate system, and then generated window and draw the grid coastline like this. Go to next slide. Now we do the orbit data and get data ionospheric footprint on the northern hemisphere. And we store this data into the data underbar put data structure. For this drawing, we should store the latitudinal and longitudinal data separately. So we store the data for latitudinal, and also separately we save longitudinal information. Finally, using overlay map SC put command, we can draw ionospheric footprint on the map. Let's see how it works. Now we compare the footprint using different geomagnetic model. So we wrote level 3 data using this load procedure. Now we draw new window. Now we draw the footprint depending on different geometry model. This slide is a summary of this movie. In this movie, we provide how to load ERG orbit data using the different load procedure. We also introduce how to plot ERG orbit data. Additional information about the appendix will follow